Today we're going to start talking about operations with functions. This is section 9-4 of our book, but let's first look at what the objectives for today are going to be. We want to find the sum, the difference, the product, and quotient of function. And we all know sum, difference, that means adding and subtracting. Product and quotient, that means multiplying and dividing. But we're going to do that looking at different functions. We're also going to look at the composition of functions. That's where we're going to be combining some different functions and creating new ones. So let's start off by looking at a couple things first. Just like we talked about with the objective, we're going to be adding and subtracting. We can combine different functions that way. When we combine, we create new functions by combining the two, like I said, through addition, subtraction, multiplication, and division. So let's first look at this example. We're going to be using these same functions through the first few examples, actually through the majority of the examples. So this function here says f plus g of x. You can see right here I have f of x is 4x squared minus 2x, and g of x is 2x plus 3. So I want to take f plus g of x. What that means, another way to think about that is if I take f of x, the function f of x, and then add g of x to it. So again, as you can see, we talked about here's my f of x function, here's my g of x function. So I'm going to take f of x, 4x squared minus 2x, and then add, I'll go ahead and put this in parentheses, and then add 2x plus 3. So what this turns into is just combining like terms. So I'm adding all the way across here, so I can see that my like terms are the negative 2x and the positive 2x. So negative 2x plus positive 2x, those cancel out. I can't combine anything with this 4x squared, so I'm left with 4x squared plus 3. There's my new function, f plus g of x is 4x squared plus 3. Good, so that's adding the two functions. We'll look at the same two functions, but this time I want to subtract them. I'm going to take f minus g of x. So very similar to the last one, let's take f of x and then subtract g of x. Just like before, f of x has not changed. That is still 4x squared minus 2x. And go ahead in parentheses. This time I'm subtracting 2x plus 3. Now the big difference between subtracting these two functions versus adding is that I'm not subtracting one term, I'm subtracting this whole function. And it helps to put them in parentheses like I have, because going through this now I need to change the signs. I need to distribute this negative sign out front. So essentially what that means, I'm going to change the signs. I'm going to change that to a plus, and when I do that, I need to change both signs on the inside. Now it's a negative 2x, and now it is a negative 3. But just like before, I am now combining like terms. So this 4x squared, there are no other x squared terms, so it's going to stay 4x squared. This time I have a negative 2x plus a negative 2x. A negative 2 plus negative 2 ends up being negative 4x. So that's taken care of. That negative 2x is taken care of. That negative 2x is taken care of. Then I'm left with this negative 3. So this time my new function f minus g of x is 4x squared minus 4x minus 3. Moving on. The third example will be f times g of x. And very similar before, we're still combining the two in some way and getting a new function. So think of this as f of x times g of x. So once again, I can take both of these, put them in parentheses, 4x squared minus 2x times 2x plus 3. So now I need to FOIL this. Since they're both binomials, I can FOIL, which works out well for us. As we all know how to FOIL, we take this first term times the first term and the second one, and so on. First, outer, inner, last for the FOIL. So that's going to turn into 4x squared times 2x, 4x squared times 3, negative 2x times 2x, and then negative 2x times 3. So multiply all those together now, and the 4x squared times 2x is 8x cubed. 4x squared times 3 is a positive 12x squared. Negative 2x times positive 2x is negative 4x squared. and then negative 2x times 3 is a negative 6x. Combine like terms here one more time in the middle, and I'm left with 8x cubed plus 8x squared minus 6x. So we've done adding, we've done subtracting, we've just completed multiplying. Now let's look at dividing. This time we're looking at, as you can see, f divided by g of x. So again, another way to think about this is f of x divided by g of x. So let's take a look at what f of x is. So 4x squared minus 2x over g of x, 2x plus 3. I cannot reduce anything, so right here is what I'm done. One thing I do have to pay attention to, though, as we all know, we cannot divide by a 0. So I need to figure out what x cannot be equal to. So what I want to do is take my denominator and set it equal to 0. So 2x plus 3, and we know we cannot have 0, so I want to say that it is not equal to 0. And I want to solve this for x. So 2x cannot be equal to 3. To divide by 2, x cannot, I'm sorry, that's a negative there. X cannot be equal to negative 3 halves. So we know that this right here is my new function when x is not equal to 3 halves. Because I'm dividing, I end up with a new, my new function. I may or may not have the same domain than my original functions did. In this case, I know that my new domain is all real numbers except negative 3 halves. So like I just said, it may or may not have a different domain than both f of x and g of x. Again, I'm combining it into a new function. Here's my new function right here, and the domains might be a little different. So on some of these, I do need to clarify when I am dividing like that. Moving forward, so not only can we combine two functions like that, but we can also, let's talk about the domain there, we can also take f plus g of 3. And if we remember back to, we just found out what f plus g of x was. So we just found out from our previous examples that f plus, excuse me, rewrite this now, f plus g of x was 4x squared plus 3. So when I have f plus g of 3, f plus g of x is this function right here. And when I'm looking for f plus g of 3, what that means is I am plugging in the 3 for x. So let's go ahead and do this. So f plus g of 3, like I just said, plugging in 3 for x, 4 times 3 squared plus 3. Order of operations tell me to square this first. 3 squared is 9. 4 times 9 plus 3. 4 times 9 is 36. 36 plus 3 equals 39. Good. Let's look at number 6, f minus g of negative 1. Very similar. I first need to remember what f minus g was. And without going back, I'll tell you that f minus g of x, as we found out, was 4x squared minus 4x minus 3. There's f minus g of x. So now I want to look at f minus g of negative 1. Very similar to what we did over here in number 5 of f plus g of 3. Now I want to do with negative 1. So I need to take this negative 1 and plug it in my function for x. So f minus g of negative 1 equals 4 times negative 1 squared minus 4 times negative 1 minus 3. Negative 1 squared is positive 1. Negative 4 times negative 1 is positive 4 minus 3. 4 times 1 is 4. 4 plus 4 minus 3. 4 plus 4, 8 minus 3, as we all know, is 5. So f minus g of negative 1 would end up being 5. Let's look at a couple more of these. Let's try one with f times g of 2. Again, as we have done previously, let's look back and figure out what f times g of x was. And f times g of x was 8x squared. I'm sorry, 8x cubed plus 8x squared minus 6x. Just like the other two previous examples, we're plugging in this 2 now for the x. So when I'm moving forward, f times g of 2 is going to end up looking like this. 8 times 2 to the third plus 8 times 2 squared minus 6 times 2. Order of operations, again, going through here, 2 to the third is 8. So 8 times 8, 2 squared is 4. 8 times 4, negative 6 times 2 is negative 12. So 8 times 8, we all know, is 64. 8 times 4 is 32, minus 12. 64 plus 32 is 96, minus 12. 96 minus 12 is 84. So f times g of x equals this. F times g of 2 equals 84. One last one. Let's look at f divided by g of negative 2. And comparing this to what f divided by g of x was, one last time, I'm going to go, f divided by g of x is 4x squared minus 2x all over 2x plus 3. So now, just like the previous examples, I'm going to go f divided by g of 2. And once again, plugging in 2 for x. So this is going to look like this. 4 times 2 squared minus 2 times 2 all over 2 times 2 plus 3. I'm sorry, this is a negative 2, so I need to include negatives all over the place. So negative 2 there, negative 2 there, negative 2 there. We'll put it there. So again, order of operations, negative 2 squared is 4. So on top now, my numerator, I have 4 times 4, positive 4. Negative 2 times negative 2 is a positive 4. All over 2 times negative 2 is negative 4 plus 3. And treat the top and bottom kind of as grouping symbols. Work with those individually first. 4 times 4 is 16. 16 plus 4, negative 4 plus 3 is negative 1. 16 plus 4 is 20. 20 divided by negative 1 equals negative 20. Good. Moving forward, we can also look at a different way of combining functions. As you can read here, we can also combine functions using what we call a composition of functions. If the composition of function is performed, the second function is performed on the result of the first function. What that means, we'll usually see it like this. This is read f of g of x, or g of f of x. And the way you work with a composite function is to start with the function on the right and then work your way to the function on the left. You will also see, I'm going to look at this f of g of x. Another way you will also often see this written is f of g of x like that. Notice the 2 parentheses back here. So work on the function on the right and work back left, or think of it this way, work on the function on the inside and work your way out. So let's look at an example of this. So here's 2 functions. I have f of x equals x plus 1, and I have g of x equals 3x minus 4. So if I'm looking at f of g of x, again, another way I just told you could write that is f of g of x in that way. So as I just said, start on the inside. So I'm looking at g of x. G of x is 3x minus 4. So what I want to do, I don't have anything else to plug in, so I'm just going to take f of g of x. G of x is 3x minus 4. So this tells me, just like in my previous examples where I took something and plugged it in for x, now I can see what I'm plugging in for x. I'm plugging this 3x minus 4 into the f function for x. So what that's going to look like now, I have my function x plus 1. This goes in the place of x. Let's change colors on you here. 3x minus 4, again, I plug that in for this x right here, and then I'm left with plus 1 on the outside. And then I get into something that's similar to our previous examples, just combining some like terms. I'm left with 3x, negative 4 plus 1 is negative 3. Just as we can take f of g of x, let's flip this around and try g of f of x. So this very similar process, but we're going to get a different function. So again, to think of this another way, I can write this as g of f of x. And again, think to yourself, I'm starting on the inside, so this time I'm starting with f of x. So this is going to be equal to g, f of x is x plus 1. So g of x plus 1 now. Just like the last example, I'm taking this x plus 1 and plugging it in for the x. So this time it's going to look like 3. And I'll switch colors on you here. X plus 1. On the outside, I have the negative 4. So now I just want to distribute. 3 times x is 3x. 3 times 1 is 3, minus 4. Once again, like terms, 3 and negative 4 is negative 1. Good. So that gives me both g of f of x and f of g of x. We can also do something like this. F of g of 3 is how I would read this. Notice I have two new functions here. So I have f of x is 2x plus 3. I have g of x is x squared minus x minus 2. If I'm going to rewrite this, I would rewrite it as this. F of g of 3. The process is still the same. I'm still starting on the inside, and what that means, I'm starting with g of 3. G of 3. So that's going to look like this now. F, and now I'm plugging this 3 to my g function for x. So I'm plugging the 3 here, so it's going to be 3 squared minus 3 minus 2. Some bigger brackets here. So I'm working on the inside here first. So f of 3 squared is 9, minus 3 minus 2. 9 minus 3 is 6. 6 minus 2 is 4. So now I'm left with f of 4. I need to take this 4 now and plug it into my f function. Again, starting on the inside. So I took g of 3 first, plugged in 3 for x into my g function. Now I've whittled that down and I got f of 4. Now I need to take this 4 and plug it into x for my f function. So f of 4 then is going to look like this. 2 times 4 plus 3. Again, I got the f function right here. I got the 4 from g of 3. 2 times 4 is 8. 8 plus 3 is 11. So I would say that f of g of 3 equals 11. One more example. Let's try g of f of 3. Again, the same number, I'm using the same functions, but we'll get a new function this time, because I'm flipping around what comes first. So another way to think about this, again, is g of f of 3. So starting with this now, starting on the inside with f of 3. So I'm plugging that in for x, 2 times 3 into the f function, plus 3. 2 times 3 is 6. 6 plus 3 is 9. So now I need to take g of 9. Here's my g function. Here's my x's. I'm plugging in 9 for those x's. So this is going to look like 9 squared minus 9 minus 2. 9 squared is 81 minus 9 minus 2. 81 minus 9 is 72. 72 minus 2 is just 70. So g of f of 3 equals 70. And that concludes today's lesson.